That spells out as doc, by the way. Phil.
You got it. That's right. We're just two docs now. We can call each other Doc.
Up, Doc.
Yeah. What's up, Doc?
Hello, everybody. Welcome to OpenCV weekly webinar. And today we have with us Kat Scott, who is the developer advocate at Open Robotics. And today we are going to talk about TurtleBot IV. It's very exciting. And I'll give you a chance to introduce yourself, Kat, in just a bit. We also have with us with Phil Nelson, who is the director of content and creative. That spells out as doc, by the way. Phil.
You got it. That's right. We're just two docs now. We can call each other Doc.
Up, Doc.
Yeah. What's up, Doc? Good morning, everybody. Once again, it is I, the co-host with the co-most, the second banana who is second to none, your plus one and only Phil Nelson. And I'm here to remind you about a couple of things we do every single week here on OpenCV Weekly Webinar, one of which is a giveaway to you in the audience. Satya, would you like to tell them what they'll win if they answer our trivia question later in the show?
Well, I would have loved to give away TurtleBot 4, but it's very, very expensive. So we will give away OpenCV AI Kit, OGD Lite, to whoever answers the
Which is
question.
what I'm using as a webcam today, by the way, everybody. This you don't get this for free. It is a great webcam, though, 4K. I'm using OBS here to pipe it into my system in case anybody cares about that. The other thing we do here on the show is Q&A from you in the audience. Please use the Zoom Q&A button at the bottom of the screen there to ask your question at any time during the show, and we'll do our best to flow it into conversation, or to we'll save time at the end to answer any that we don't get to. Satya?
Yeah, so Kat, welcome. Why don't you start with a quick introduction, and then we'll go over your presentation.
Cool. Yeah, so I'm Catherine Scott. I'm the developer advocate over at Open Robotics, which means I sort of do a lot of the community management, outreach, work on stuff like TurtleBot and a few other things. And if you're not familiar with Open Robotics, we're the sort of steward organization for Robot Operating System, or ROS, which includes ROS II, and simulator called Gazebo. And then we have a new product. It's called RMF, or Robot Middleware Framework. And so that is basically a set of tools to connect a bunch of robots together and do some planning. And that's all open source. Yeah, and I would have liked to have given away TurtleBot. We actually don't have any yet. They're not shipping till June. We're just taking pre-orders, but I have one.
It's always the problem with when you make hardware. We learned this during the original OpenCV AI Kit campaign, is when you make hardware, you never have your own hardware. You just never have it. Like everybody else has it, and you just never have it.
Oh yeah, well, no one has it yet. It's just kind of, supply chain stuff is really backed up, and it's keeps pressing out too. But we're pretty confident we can start having stuff roll out in June. So you're taking pre-orders.
It's funny, a lot of people do not know the history of Open Robotics and OpenCV. We originated from the same company. Willow Garage at one point was managing both Open Robotics and OpenCV, and we split from there. And now we have come full circle with OpenCV AI Kit being part of TurtleBot.
The twin quasars of open source engineering.
Or a subset of it, at least.
All right, let's get started.
All right. Well, why don't I share my screen? Boom. We good? You guys see that?
Yep.
All right. Let me make it full screen. All right. So let's talk about TurtleBot. But let's start with some history, because I like to start things off with history.
Are you also seeing these black
Yeah,
boxes?
there's a couple of slashy privacy bars. You see this?
No, I do not.
I'm not sure what the deal is. It's some kind of screen share thing. I'm not sure.
Maybe you can try restarting the screen again. I see these privacy boxes completely blacked out.
Yeah, it's like they're there to hide sensitive information or something.
Really?
Yeah.
Oh no, it's the Zoom. It's because it's the Zoom control thing. So she can. It's just hiding the Zoom screen share.
Oh,
I see.
Controls. Can you move those to a different display or hide them somehow?
Yeah.
Yeah. There we go.
Oh, yeah.
Perfect. Yeah,
You're the smart one.
Yeah, much.
Well, so they always get in my way too. Like when I volunteer teach and stuff, it's like the Zoom control is not. Great.
I agree.
Anyway, you guys can see everything now?
Yeah, it's better. I mean, there's still kind of crowding the corner of the screen there, but if we can't get rid of them entirely, you know.
Okay,
oh, hey,
done.
there we go. Perfect.
Okay, great.
Range.
Oh,
All right.
Oh, wait, they're
early,
back now.
but it's fine.
What the hell?
Okay. Let's see here. Can we do this? I think that's as good as I'm gonna get.
Yeah,
here.
that's perfect. The other one, the box. Okay.
That's probably good enough.
All right. Well, so let's talk about some history. Let's go back to like the 60s, 70s, 80s computing history. So TurtleBot is this sort of lineage. It comes from this long history of building robots, building like educational tools for software engineers to make more software engineers, right? So in approximately, I think it's 67, I got it on the next slide. There's this guy, Professor Seymour Papert, Professor Cynthia Solomon, this guy, Wally. They're all kind of working together. They, were early, they all sort of collaborated together at MIT. They're sort of the people that were the inception of the MIT Media Lab. Seymour Papert went on to work on Lego Mindstorms, One Laptop to a Child, which was this project that was that about 2010 or something like that, trying to build a super cheap laptop. And it was sort of subsumed, I think, not subsumed, but it's sort of the precursor, I think, to the Raspberry Pi, right? Let's build a super duper cheap open compute module that people can use for learning. And then Cynthia here and Wally, they went on to work at, well, it's not really Raytheon. It was BBN Technologies. They were acquired by Raytheon a few years ago. BBN is a really interesting company. You should look at the history of BBN because they're the ones who built the internet. They built the early internet. They were the sort of prime contractor when DARPA was like, hey, we want to build this giant network to connect all the computers. Can we find somebody to do that? One thing to note here, this is actually one of the precursors to TurtleBot right there. Okay, so Logo was this language, this educational programming language designed in '67 by these people. It's not
the first thing I ever wrote code for was to draw a little circle with Logo. Yeah.
Yeah. So it's not an acronym. They just coined it. It derives from meaning thought. I put a really nice little article right up about the history of Logo down here in the corner. But it's just this really simple language where you kind of assume that you're like a turtle and you can go forward, you can rotate left, you can rotate right, you can go forward, and you can build these fairly complex graphics out of a turtle.
Just with those those were all the commands available to you to draw. So that's So, people that are younger than us might not know how this works. Yeah. But it was a really cool. It was really great for education because it was especially in the the monochrome display days. This was a great way to visualize this sort of almost how like an early way to write an algorithm for people that didn't know how to use computers at all yet.
I mean, you have to think at the time, right? This is like Pong was fancy. And Pong was actually fairly late in the game, right? But you need a very simple. We're talking like a terminal like that, right? You need to be able to draw on it. How do you do any sort of graphics work on there? So this is like basically Logo became sort of this open sourcey thing where people used it for education. It ran on the Apple II. You could get a variant of it for Atari. I picked this up at a swap meet or the Vintage Computer Festival. I actually have this Valiant Turtle robot from 1983, which is, you think about it, really the precursor to TurtleBot.
Wow. That's awesome.
Yeah. And it says on here, I don't know the provenance, but it says Mark III prototype. So this is a prototype. And what you can see here is, I'm not going to remove this shell because it's pretty fragile, but underneath here, there's actually a little hole for a pen. And what you would do is you would connect this to your Commodore 64, and you could send it commands, and you could actually, do some sort of spirograph drawing, kind of like that.
Like a pen plotter.
Yeah, it's a pen plotter. I mean, it's basically a pen plotter for kids.
Oh,
and
That's so cool.
My kid, there's one that's the exact same thing.
Wait.
Is okay.
I got it. I got it
Oh, you
covered.
got it?
All
Okay.
right. So this this is sort of the provenance of all this turtle stuff, of all these sort of drawing robots, and you can see it today. You can see the history. This is an iRobot. They sent me one of these. This is a iRobot Root. It was a company, I think they were acquired by iRobot. Very, just this other robot evolved, right? It's just a pin plotter. There's a little lever in here where you can put a dry erase marker. And it actually, it's kind of cool. My desk is metal and it has magnets on it, so you can put it on a wall.
Oh, that's cool. So you could have it on like a whiteboard moving around there. That is badass. I want one of those now.
Well, we got the big boy version. I'll show you in a second. But you can kind of, I guess the point here is that you can see this long history of, hey, we're going to build a robot. What do we want the robot to do? Well, the best thing we can think of that's fun to play with is to draw, to move around. I think you can even see the lineage of all this in things like Scratch on the Raspberry Pi, because it went from like OLPC, the one laptop per child, to, hey, well, let's make about 10, 12 years ago, let's make this tiny $50 computer that is affordable and get kids programming in a very simple, manner. All right, so approximately 2007, as Satya mentioned, there was this place called Willow Garage, and they built robots like the PR2. They built the early versions of ROS and PCL and OpenCV. I just said that. So all these projects are sort of born out of Willow Garage, and it was like, well, how are we going to teach people about these things? And the first iteration was that there was this thing called Turtle Sim inside of ROS, where you could pop up a simulated turtle. This is probably the first ROS simulator, and you could just move it around the screen and program it in ROS doing the old school turtle graphics. So that was great, but real robots are better. So TurtleBot 1 was born. Early logo from TurtleBot 1. This was just at like right place, right time. This TurtleBot, let's go on the hardware here. There's a couple of laser cut plates, some
I'm going to be
stand-ups.
very disappointed if there's no video somewhere on the internet of an actual turtle on top of that platform writing this thing.
We can make it happen.
Please, somebody in the crowd find footage of this and send it to me. Yeah, that's your homework, audience.
So this was, okay, what made this thing possible? $200 Connect. This is like sort of the era, like 2009-ish, where you're starting to see the like $200 Best Buy special laptops. I think the first base was a Crate. This is the Crate 1. So very, very primitive, but it had the juice to do basic like autonomous mobile robot stuff. So this was built by, these are some hilarious photos. This is my coworker Tully, and this is Melanie Wise. Melanie went on, if you're not familiar, went on to build Fetch Robotics, which was just acquired for millions of dollars. But they build, robots like this, where it's basically a mobile base with an arm, and then a lot of these sort of AMRs for doing logistics work. So it's really cool to see this like evolution of something that's a learning project or a toy into something that's a real product. These are how real products get made. They're not usually perfect from the start. They're evolutions of sort of things put together. So then, I don't believe we sold a ton of TurtleBot 1s. They were more of like a DIY project. So then it was like, well, we really need to get more of these. So the TurtleBot II came along. It was a very similar design, except that, you're looking at, this is a Kabuki base, which was another sort of mobile base vendor, and then still the very first Connect. These things were beasts, by the way. Had like separate power cables.
Yeah, like it's really like not made for, it's the original Connect is such an interesting piece of hardware, because I can't think of one in modern memory that was so like twisted from its original purpose to be so much more useful than they ever intended it to be. I mean, multiple companies were launched on just making stuff with the Connect. It's really an interesting piece of hardware.
And Microsoft thought it was going to be, it was such a revolutionary piece of hardware, but Microsoft, thought it was going to be a huge boon for like gaming, and you'd be like waving in front of your TV. And, they were really trying to, it was too new of a technology, and they were truly trying to find a solution for it. And I don't think they stumbled on the right one. But it was a boon for TurtleBot. The one thing
Yeah,
to
and
note,
another little bit of history there too with the Connect is that the guts of that were made by a company named PrimeSense, which is the same company that did the internal design for Structure Sensor, and they were acquired by Apple during the first Kickstarter campaign for Structure Sensor.
Oh, really?
Yeah, so
Yeah.
that's we'll
I
save that story for another
I,
episode. But
I remember that. You guys were freaking out.
oh yeah. All right. Sorry, Kat. Go ahead.
No. So, okay. So the thing to note here, missing a LiDAR, no LiDAR. There were no cheap LiDARs at that point. So TurtleBot III, this was, these are still available. These are manufactured by a company called Robotis. They came in two variants. There was the Burger, which is this little tiny, I have one half taken apart right here, desktop version.
It makes you think of Burger Time, like you walk across the top and the top falls down.
Yeah. Well, I was doing some work at some point and just gave up. What we can see here, this one, out of the box, just maybe a Raspberry Pi camera, but no depth camera, but it had a LiDAR. And then there was also this bigger version. Cool. The one cool thing are these like super hackable plates here. Super cool. So Robotis
Those are
also,
really those plates are interesting. People that are watching the holes aren't just there to look cool. Those are so you can just basically use M4 machine screws probably to mount damn near anything. Yeah.
Yep.
Yeah. Really, really interesting design there.
So Robotis also makes really, really nice feedback control servos. That is like their bread and butter. If you need a servo, they do some great stuff. All right, so those are the sort of three versions of TurtleBots. We kind of, we decided that it's about time. It's been 5-6 years, time to build a new TurtleBot. Technology has evolved a bunch. So, any engineering project you think of, what are the design considerations? So the things that we liked, extensibility. It's good to be able to put new stuff on the robot. It is fundamentally a research education robot. LiDAR, critically important. Like, yeah, computer vision is good, but LiDAR just makes navigation so much more robust. You really want, at least a 2D LiDAR on it, which is to say that, navigation on these things is sort of the killer app. Being able to map a space, move around it, and then do something in that space. That's generally the killer app. Yeah. We've tried a bunch of sizes, right? You got big ones, small ones, tabletop, floor. The TurtleBot III, great on a tabletop, great on like arena or something like that, but not for doing stuff around the house. We generally like the community we built around stuff. We generally like partnering with people to build the robot. Generally, figured spend more, build a better robot, but not too much. And we had fun. So the things we didn't like, there's this whole aspect of like trade-off between DIY or like a kit and a finished product. And we ended up coming down on the side of, well, finished product is generally going to be better because we really want these in a classroom. And if you're an educator and you want to buy, 10 robots, you don't want to put them all together.
Yeah, once you get done spending your weekend grading papers, you don't want to then have to put together the robot that the kids are probably going to break.
Yeah. And then, fulfillment, we needed a robot, we needed to be able to get hundreds of these out to people. So we needed to find a partner that was able to do that kind of manufacturing. We wanted more simulation because simulation is basically making free robots for people. And I'll talk about that in a minute. I'll show you guys some sims. So we're not giving away a robot, but everyone is going home with a simulated robot today. It's like Oprah, like reach under your chair. There is a simulation. There's a GitHub repository under your chair.
Scan the QR code under your chair.
Yeah. Big one, big thing is batteries. Include them, which gets you, like, they need to be included in the base because that gets you all the like power certification, work with somebody who knows how to ship them. And then also a charging dock. It's great to be able to tell your robot to go charge itself. Yeah. Yep. And then table versus floor, we decided floor, more computer vision capabilities, and then just better human robot interaction. Needed space for more user interfaces. All right. So So I kind of have all my notes. These are my chicken scratches all the time. We decided, okay, we got to have computer vision and LiDAR. Got to have a mobile-based charging dock. We need better ability to do human-robot interactions, at least like a little screen or something and some buttons. We need a power distribution system. And I really, really think that we should, we should be more forward-looking. Let's use USB-C so we can do power and data. It's a little bit early, but I think it's about time. Back to base, and then simulation.
Right. So one other thing you mentioned, computer vision and LiDAR,
Mhm.
but are there other sensors like the touch sensor and other things are also there, right?
Yeah. So there's on most of the mobile bases, there is a cliff sensor, a bump sensor. Some of them have like a 1D, 2D LiDAR. They at least if they're a vacuum, right, they need to figure out where the edge is. So they at least have that. IMU, but I'll talk a little bit about that, what's in there.
Okay.
But yeah, so we're putting all this together in the middle of pandemic, it was kind of like right place, right time, right partners, everything kind of fell into place. So Lexonis had just shipped their first hardware, and we were super excited about the Oak D and the Oak D Pro. And it's like, we can get this much compute with this much power consumption at this price point. It was almost a no-brainer at that point.
And they were actually available.
Yes, they were available
to buy, unlike a lot of companies.
Right.
Yeah. So it was like, let's work with them. Another big one, iRobot they actually came to us before they shipped, and we're like, hey, we're building a new robot. What are your needs? What do these things look like? Can you give us some feedback in the process of building this mobile base? So they were a great partner. All of the new iRobots actually run ROS 2 underneath, which is amazing. It's fantastic.
That's a big milestone for ROS.
Yeah, I mean, they only mention it on the Create, but I believe it's all of the new robots.
Wow.
Because this is the same base they use for everything else. This is just fantastic. It's a commercial build quality. They're moving in a much more open source direction, which is fantastic. It's got a charging dock. It's got all the certification. It's got both sensors, and I believe there's like a state estimator in there. So you have like wheel odometry and an IMU and a few other things in there. And so it actually has a pretty good sense of where it moves. And so the problem with the Create One, and I encountered this in grad school because I had to work on a Create One, was that you would say there was no feedback control. So you would say, move forward for, at this rate for 30 seconds, right? Like spin the wheels. How far you went depended a lot on the slipperiness of the surface that you were on. So you really didn't have a good sense of how far you moved in any one direction, or how good at doing the thing I told you to do you did, if that makes sense.
To bring it around for people that are dumb like me, sort of like the ice levels in Mario.
Yes, ice levels. TurtleBot's on actually down in Silicon Valley. Tully, who built the TurtleBot, does the robots on ice every year down in Silicon Valley.
That sounds extremely fun.
Yes, there is a robots on ice.
So Kat, could you explain a little bit for people who don't know, which includes me, what is Create 3 and Create 1?
So a Create is iRobots, like they take the vacuum out and they just give you everything but the vacuum.
Got it.
Right? So okay. It's basically their hacker version of the Create. It's I want the base.
Okay.
Yeah. And then the big, huge partnership was right place, right time. Clearpath came to us and they're like, let's go build a robot. Clearpath, if you're not familiar, they're one of my favorite companies. They're a Canadian research robotics company. And so they have multiple divisions. They also have like a vehicle autonomy AMR component too, but they build. So if you're like, say you want to do like research for like a Mars rover, but you're not going to build a Mars rover. You want to like work on, say, the subsystem that, I don't know, moves I'm just throwing stuff out here, but moves the solar panel during the day to optimize like, power distribution or something like that. You want to work on that problem, but you don't want to build the robot. They'll ship you something like this Husky over there. And so it's all put together. You just write it into your grant. It comes up. They're just really, really good at building, robots, these sorts of robots that aren't mass produced like like the iRobot crates or something. They're more like low rate production. They're going to build a few thousand, few hundred of them, and they're going to be kind of expensive. They're all up in, I think all their offices are up in Ontario. They're all just, I don't, if you've ever worked with Canadian engineers, they're always just amazingly talented and well-trained. And it's a joy to work with them. They're super polite. They're incredibly efficient.
Nothing but love for Canada on this show, unlike those filthy Iowans.
Yeah, agree. Yeah, and they're just wonderful people to work with. And they use the thing is they're a big ROS shop. They use ROS every day. We write ROS, and so we use it, but they really use it. They put it on robots, they send it to people, they got to make it work, they got to ship it, it's got to work. Oops. So we came up, and I'll talk for a minute, and then I'll do some demos here real quick. So kaboom, we built the TurtleBot 4. There are 2 versions, kind of like TurtleBot 3. On the left, you can see the light version, which is just the, let's make, the MVP version of the robot, the cheapest, I don't want to say cheapest possible, but the least expensive, because we really do want to get these into everyone's hands. And then there's the standard edition here, which is a little bit more of a souped up. You get, it's the higher trim level. You get the OpenCV Pro versus the OpenCV Lite. You get a lot more power distribution capabilities, ability to sort of mount stuff everywhere. They're both really, really nice robots. Spec sheets. So you can see that they switch sides, unfortunately here. Sorry. So TurtleBot Pro, you're going to get a little bit heavier. TurtleBot Lite, you're going to be a little bit lighter. Fairly, crazy payload, 9 kilograms on these things. So you can put close to 20 pounds of stuff on there and it'll still move around.
Yeah, I mean, like large dogs, large children could ride on
turtles.
These
things. Right. Turtles could ride on.
Yes, finally.
Yep. About half meter per second. Charge time is about 2.5 hours. Operating time 2.5 to 4 hours, depending on load. You really want you can take this robot and you can put it in a fairly sizable warehouse, and it can go around and it can map the whole thing, which is fairly nice. Both of them have the RP LiDAR, which is, I think this is the newest one at about 1 degree of angular resolution. Fairly nice LiDAR for the price point. And then again, OpenCV Pro and OpenCV Lite for vision. And then as you were asking, this is the full list of sensors. We got 2 front bumper zones, 2 wheel encoders, IR cliff sensors, IR obstacle sensors, optical flow sensor for odometry. So it's doing its own sort of state estimation odometry internally. Gyroscope, accelerometer, and battery level monitor.
Sweet. Those cliff sensors are real important.
Mm-hmm.
Right. And the IMUs, are they through the OpenCV Pro and OpenCV Lite, or there is an external IMU as well?
So internal to the Create 3, there is an IMU, but you can also use, I'm sure you can use the one on the OpenCV as well. Okay. Or you can, sanity check them off each other. If you want to do something like pose fusion.
Yeah.
Probably, if you want to go learn pose fusion and write a ROS node to do like odometry from pose fusion between the 2, I think that would be a super cool feature.
Right. Again, and IMUs are so noisy. It's good to get multiple of those if possible, right?
And the ones that aren't noisy you're like 10x the cost of the noisier ones. Yeah.
Totally. And yeah, I'll talk about a couple of features that I like on this thing, and then Raspberry Pi 4B, the 4 gigabyte version, because there's a lot of different variants. And so, like I said, killer app, runs Nav2, which is the ROS 2 navigation stack out of the box. Between the OpenCV, I mean, generally most of the navigation is just on the OpenCV, but you can also, or using the RP LiDAR, but you could also use the OpenCV if you wanted to. And the thing is with the OpenCV, because it's got onboard compute, you've got a lot of space on there to go and deploy models, to go build stuff, to build more complex behavior. You're not straining to do both like mapping, navigation, and some other sort of compute, which I think is really, really important for this sort of, where we're at in robotics.
Yeah, it's not a camera, it's a compute plus camera.
Yeah. Other thing, this was my like big requirement here, is that it have a screen.
Some screen, I love it. Yeah.
It didn't have to have a big screen. It doesn't have to have a huge touch screen, but it needed some degree of UI. And this is important, right? Because like, if you've ever worked with a TurtleBot, you know that like, hey, I'm going to go take it to show off, and then I'm going to have to like connect to it and in somebody else's network. So I need to know like what the IP is. I want to get it to, the thing I harp on, like when I have like interns working on a project, is like, okay, this thing has to be so easy to use. You have to be able to press a button. And before, there was never like, oh, here's a menu, press a button, run the robot behavior. And now we can get to that. Because I think that level of finishing is really, really important. And
well, yeah, and even just having stuff like the battery state and the IP address available at a glance like that saves you like 30 seconds to a minute every time you do anything, Like when you're working on this stuff, a lot of the time you're writing some code, you push it to the robot, and then you have, you restart the bot, right? And so you might have to, if you see that IP address is incorrect, then you don't have to guess if the IP address is right when you're debugging. Like there's certain things you just know when you have a UI, even just a very rudimentary and cheap one. I agree strongly with that. There should be some kind of screen so it can tell you what's going on.
Yeah, there's also speakers. It can make it can play some music.
Awesome.
Nothing fancy, like a buzz speaker, not like a full speaker.
Like a piezo, or?
Yeah, I think it's a piezo speaker. A piezo speaker. There's also a couple LEDs on here. I like this kind of stuff. I'm not the world's greatest debugger, so sometimes I will do, like, say you have like a state machine in your robot, it's changing state, and you want to see when those state transitions happen to make sure they're running. It can just flash a light. You can put a message out on the screen. It just makes your life easier when you're building stuff. And I think it's important to give people these little toeholds into debugging stuff. It doesn't always have to be, you shouldn't have to always SSH into it and like run the debugger internally and all these things. A print message for some of the stuff is totally fine, or print light. So other things, this is a render. I don't actually have the full version of the light version. I'll show you guys in a second here. But this is the TurtleBot standard. So this one actually, and I'll show this in a second, moves the Raspberry Pi up out of the drawer. There's actually a drawer in here that you can insert stuff, but it moves it up here so it's a little bit easier access. And then there's actually power distribution over here on the sides. So, you can see the mezzanine on the robot. You're able to go and plug stuff in, put it up on the mezzanine, and use it and power it through the robot. And
mezzanine,
the reason
the second floor?
Yeah, the second floor, right? The second and third layer. And the reason we did this, right, is that there's this sort of developing community in ROS called micro ROS, and this is essentially a subset of ROS 2 that's built for microcontrollers. So things like, think your Arduino or your Teensy or your ESP32s, all of those boards or all those microprocessors, you can basically install a couple flavors of a real-time operating system, run micro ROS, and then basically have the thing natively talk ROS back and forth. This is a huge step forward, because in ROS 1, you're generally just doing everything through a serial connection. And, once you got stuff out of ROS into serial land, you're on your own. And so now we've moved a lot of those embedded system, or a lot of the like ROS paradigms into embedded systems to make life easier, get things closer to plug and play. And hopefully people can actually go and like build tooling and build new sensors and build new actuators that can go on these robots. So really, really what I want to see people like, pulling, say, like a Teensy out of their drawer, dropping it on this robot, building some sort of like, I don't know, weird whisker sensor, or, stupid, any sort of dumb servo sitting on the top where like the robot bumps into something and it has like wings that move. I don't know, but
I
it's
like the idea of curb feelers, you know, like get some
yeah.
like you'd put on a Cadillac.
Yeah, and so we've made this whole process, right, of building on top of the robot to do stuff easy though, and I think that's super important. I'm gonna pause here. I'm gonna show you guys the robot and and then I'm gonna show you the simulation. So we had and I was talking to Phil, it apparently hit Phil too. We had a brownout PG&E about a week ago, and I went to go power up my robot, and I think we fried it. We fried our garage door the other day. So robot is not operational at the minute. It was working last week, but I'm gonna like give you guys a good look of what's in there.
Yeah, go ahead and unshare your screen when you do that so we can get the full
All right.
view of the bot.
Yeah, let's do that. And then I'll show you the simulation here. Let's see. Oh, I gotta move this thing back. Stop share. All right, cool.
There we go.
All right, so I actually was debugging this last night, so it's on my floor. But the cool thing about this robot is that it comes apart. So I'm going to take the top off first. I'll put it together. So this is the top plate. And what you can see here are two buttons. Okay, you can see OAK Pro and the RP LiDAR. And what's going on here is there's these holes. I think they're M2 holes. So this is all mounting plate on the Create 3. And then there's actually a very nice bent aluminum or bent steel OAK mounting plate, which I thought was cool.
Oh wow, that is nice.
Yep, and these guys pop through, and what you can do, I'm gonna pull the rest of the robot up, is you can, so here's the actual Create, and so you can see the guts here. There's basically, here's the Wi-Fi board and Bluetooth board. Here's sort of the main like display board and control board for the Create. But what's really cool is it's also got this tray that slides out that you can actually shove all your electronics into.
Nice little gear sled there.
Yeah, it's actually weighted too, so the thing's balanced out.
So that's the way the dust used to go, is supposed to go, right? Okay, the dustbin they have converted.
Oh, for when you're using it in vacuum cleaner mode?
Yes, yes.
Yeah. Yep. Underneath standard Roomba, and then what's really nice is, hey, this has got a UI. It's got like a little ring light here and a couple buttons that you can use to interact with this. And then I love this. So you can actually disassemble and reassemble it without any screws. So you can drop this guy in here, and this guy just pops in like, I don't know if I got it fully, but pops right in, robot goes back together. So if you're like pulling it out to say flash it or take it apart or install something new, I mean, because that's generally what we want people doing with these things, is taking them apart, putting them back together, doing stuff on them.
I really like I liked hearing the thought process there, because it makes so much sense. I mean, it's clear that this was, you know, designed by people that work on robots a lot and have that round trip problem of, if you can shave off those the rough edges on the round trip of write some code, deploy to hardware, attach hardware to bot, you know, you're essentially like having the amount of time it takes to make a change, which is huge.
I'm gonna pull up the simulator real quick so you can see this. I have a really slow desktop, so this isn't gonna like cruise. Can you guys see this? Or no, I got a screen share
again, yeah.
And I'm trying to fit this all in one screen, so it's going to be a little bit crowded.
That's all right.
It's all right.
Brave live demo. We love the gambare. We love the you can do it. We love the demos here.
So this will this should give you, let's see here. Start this guy. Good. There we go. So on the left here, this is Gazebo, which is I think I press. I got it. So, all right, let's walk you through here. On the left, I know this is all kind of squeezed together, so let me...
Hella range on that LiDAR, geez.
Yeah, so this is Gazebo, the newest version, or yeah, I think it is Fortress or Edifice. So this is our, and things are really laggy for me because I got the screen share and stuff going too, but so this is our simulator. So we can simulate the robot with physics, with graphics. It's, you know, running at about 1/10 real speed here, but you can speed it up if you use a smaller environment. Oops.
Nice textures on those girders.
Thank you. Let's move. All right, I'm gonna scroll back in here. And then we basically have a, uh, these are basically the controls on the robot itself, so you can simulate it. So this would be the screen on the, this is the full robot or the standard TurtleBot. So here are all this, here are all the controls on it, as you would see on the screen. So I think I can do this and it should undock. Yeah, it's running it like a lot slower. So you can also see there's like the indicator lights up here that'll blink and do stuff. And you can go and you can actually move the robot around. Let's see if I can get it to undock.
I have a much cheaper robot vacuum here in my apartment, and so I have this Pavlovian audio response to seeing this thing that I keep waiting to hear the beep noise that mine makes when it moves away from the dock. It's the same, you know, you get used to it.
Yeah, so I'm just going to move it off the dock a little bit here, and then I'm going to show you. Okay, so this is, I don't know if you've seen this. This is Arvis. This is sort of the internal ROS visualization tool. And what you're seeing here is you're seeing the robot move around. This is the TF tree, which is all the transforms, all the position differences
All
between
the normals and
parts of the robot. Yep, and it's you know, coming off the dock, it's rotating around. And then what you see here is a 2D top-down view of, like, say, that whole room with a simulated LiDAR. And what we're doing here is we're basically showing where all the edges are, where you're going to build your map. I'm not going to sit here and do it all, but you could drive this whole robot around, build a map of it, and then say, you know, navigate from point A to point B, you know, do some predefined behavior in there. And you can do this all with the simulation. And so, like I said, we're making a robot. People should buy the robot. It's fun to play with robots, but we're also making the simulation available for anyone who wants it. So you can actually just go and learn how this all works without spending a dime, which is pretty, well, other than on a
Usually,
computer.
for a simple application, like you want to, you know, you use the simulator to create a simple application where you build the, you know, using SLAM, you build the whole structure of the house or room, and then you navigate from point A to point B. And let's say, you know, the floor is wooden floor or something like that, so that there are no surprises. In that case, that code, if you transfer it to a robot, how close is it? How much extra work do you need to do usually, you know, from simulation to actual robot?
The so this is called the sim to real problem in robotics and computer vision. And I mean, it's going to vary a lot. You know, like if you're just training the robot or programming the robot to go forward, back, do a motion sort of thing, probably will be pretty accurate. If you're doing like, hey, do some deep learning, recognize these things, could be significantly different, right? Like it
Yeah,
really is depending on the fidelity of your simulation and what parts where the fidelity matters, essentially.
right. Well, I was more concerned about the physical. So deep learning part, right? That can be handled, right? You can actually create very good models outside the simulation, right, and do it. What I was more concerned about is the physical and mechanical simulation, right? I mean, for example, you want to do dead reckoning to go to a certain place, you know, from point A to point B. Would you, how close is the simulation to the actual thing? Um,
I mean, it's going to vary significantly given the situation. Like if you're in a flat floor and it's really simple, it's going to be pretty good. If you're in like a Mars rover sort of situation where you have a bunch of
right.
different particles, you know, it may not be as good. I
But
really,
carpet versus floor, for example, carpet versus, so if I put a carpet in the simulator, would it be kind of similar? How how many degrees of freedom do I have with the carpet? Can I say that, oh, this carpet has so much, you know, it is so thick, or it has
Mhm.
such friction. I don't even know. I'm making stuff up right now.
Well, so
Uh,
it's really depends on how much you want to model it. You know, you can do a plugin. So Gazebo is built so you can build plugins like that,
got
right?
it.
That you can go and increase the fidelity or reduce the fidelity. It's really, you know, it's gonna all of these things end up really being application specific, or whether you need, you know, for example, we've been doing a lot of work with Gazebo to do maritime research, right? So like I'm, you know, say a well, I'll say this generic. I'm a big research lab that is on one of the coasts that you may have heard of that is in Star Trek movies. And I want to go send a thing out to go swim around out in the bay for like days at a time and collect salinity and other, you know, science measurements, for lack of a better term. So they need to model like all of these different hydrodynamic properties about the vehicle, and they might want to add in stuff like tides and what they already know about like currents and those sorts of information. And you can do that at Gazebo, right? You can take all that information and start building a model and try to train your robot from there, or you know, build the simulation to run your robot in.
Got it. So plugins are how um, you would try to make the simulation as close to real life
Mhm.
as possible. Okay.
Yeah. Let's see what else I got here. I just enabled the camera here on the robot as well. So this is a depth camera. This is just a simulated depth image. And yeah, I don't know if you guys can see that, but it's down there. You can see the depth image as it um,
Cool.
moves through the
Yeah.
environment. I can see what it's, let's see, we can see what it's looking at here. Oh, oh no. You can tell I don't game that much. Yeah, so you can see depth image. You have these two poles right here. You can see that they're coming up in the depth image.
Right. Okay.
Important question: does the Konami code work in this?
No,
Can
because
I get extra guys?
oh, I forgot to mention, you do with the TurtleBot, you do get a controller. So you can
Oh,
just drive it
nice.
around. Yeah, and you can enter your code and you can go and do that.
Have to add the Konami code to the repo.
Yes. So that's sort of the sim, right? And then, you know, I think that you know, all these things are cool and pretty pictures and what have you, and you can learn a lot from it. But I think the thing to keep in mind here is that, you know, this is a running ROS system too. It may be a simulation of a robot, but it is a real robot. So I can do, you know, ROS 2 topic list. I can, oops. You know, I can see all of the data that's moving through the system at any given time. Let's see, what can we, you know, what's going to be moving? ROS topic echo. You know, we could look at the TF tree. We can see like the position of everything. Let's see if I can move this robot. So this is essentially telling me like this is a TF tree. So this is the position of all the different parts in the robot in real time. All of your standard ROS things that you want to learn, like how to run the command line, how to build modules, they're all available just inside the simulation. And you know, simulation is an extremely important part of robotics now, because no one wants to be on the floor working with a robot all the time. It's a pain to debug like that. I mean, you need to do it eventually, but you try not to do it as much as you can. And it's a good time. And like I said, this is all freely available. This code is all. Let me toggle back here. I'm going to turn this off so I get some compute power back. Yeah, so I put this all in tinyURL. You can take a look at the sim. It's TB4Sim on Bitly.
Awesome. We'll include that link in the show notes, of course.
Yeah, and then so I'm in the process of writing lessons for this. So there are going to be slides. There's going to be basically people walking you through a lot of this stuff. Clearpath has put together a manual. So all of this really basic, just start it up, get it moving around for both the simulation and the robot is a freely available manual as well that you can just sort of, you know, nice clean docs, easy to use. And, you know, there's been a lot of, even if you're like not you know, a robotics person, there's been like a lot of development on interfaces. There's this company called Foxglove. They built basically, this is the control panel for one of the cruise vehicles. So you can actually use this code, like if you want to learn all these peripheral things to robotics, like how to build the control panels, or like, how to build, do front end dev for some of these robotics applications. That's all available too.
Yeah, and those are, I mean, a lot of the times we see people that they're kind of doing everything because it's a small project, it's small team, but being able to build effective kind of ad hoc, dream up good UIs for this stuff is also a discipline all of its own. I mean, you don't have to be a hardware engineer to work in robotics is an important distinction. You're muted there, Kat.
It takes all types. It's kind of like mechanical engineers, electrical engineers, front end developers, people, actually figuring out how to interact with the robot. Oh, it's an ad for Embedded Vision Summit. Anyway, yeah, so we've gotten a little bit of press. We just actually launched the pre-orders last week, so people are starting to notice, but haven't actually gotten the robot out into people's hands just yet. Yeah, and they're going to start shipping in June. The Pro, or the standard's going to be $1,850. The Lite's going to be $1,195. Or, like I said before, the simulation is completely free, and you are, more than welcome to come and bang on it and see what you can do and get interested. And then if you really enjoy what you're doing, go get an actual robot.
That's great. I'm just curious, why didn't they try to do something like a Kickstarter campaign for this? It's almost ideal for that kind of thing, right?
I don't have a good answer for that. I think it's, Clearpath is a large enough organization that,
Okay.
we don't, as a capital raising strategy, it works. And as a publicity thing, it works. But
More from a publicity point of view, it, first of all, because of the volume, you can lower the price slightly. And that becomes very attractive to people, and also the publicity, but every company has a different strategy.
Yeah, I don't have a solid answer for that. The other thing I wanted to say though is, as soon as we can, probably within a month of it coming out, this is all going to run the latest, greatest version of ROS, which is ROS 2 Humble. We're actually having that software releases on the 23rd. It's kind of a big deal. It's going to run on Jammy, which is, I mean, it runs on other operating systems, but Jammy is sort of the preferred one, 2204. There's going to be just tons of sort of, it's interesting to watch the progression of like the version 2 of the library. So if you look at the release notes, it's just like ergonomics and documentation, improvements and bug fixes. A few features are still coming in, but it's a lot, things are, you can see that like stability's really gotten here, and like things are slowing down. And then just also one last shameless plug, we're selling swag for the Hawksbill release. We've got all this stuff, 20% off until the end of till the release. Yeah, and that they all sort of benefit the nonprofit arm of Open Robotics. And I was thinking about this, and I was wondering like why there isn't OpenCV Swag, and I looked it up, and so you guys need to like harass Phil, because I want to know.
Literally in the tab next to the tab that's showing me all of our channel streaming is an order for 500 stickers that I'm about to place. So come find me at Embedded Vision Summit if you want a sticker.
Okay, and so I started searching for this. Get this. And the first thing, are there OpenCV shirts? How to put an image on a T-shirt using Python OpenCV. So now I think this Stack Overflow question needs to be the T-shirt.
Right. I'll create the tutorial.
I think we're locked into it now.
Yeah. I mean, yeah, the reason is, I mean, aren't these very low margin products though?
Generally. It's all about the community. It's just about people repping the stuff they use.
For that reason, it may be worth doing it.
Okay. Well, we got 5 minutes, so I guess I went through the robot. I filled up with a bunch of other cool stuff going on. We've got a bunch of work with NVIDIA coming in. I'm just going to breeze through this. NVIDIA's got cool stuff coming in. And the other one I want to show you, really cool system, Fog ROS, just Google that right there. This is a simple way to like take your like SageMaker model or other like cloud model and drop it on a robot. Just came out, just got released out of UC Berkeley. I also saw some incredibly, this is the cool hack I was talking about. UC Berkeley, this is Ken Goldberg's like, using UV paint to do semantic segmentation data generation for like like things that are
Oh,
soft or little needles. Coolest research I've seen in a while. Just simple hack. I guess we got. I wasn't watching time too well. Do you guys want to do some questions?
I love UV paint. It's one of my favorite things. Yeah, we should definitely do our giveaway here. So yeah, please go ahead and unshare your screen there, Kat, if you
Yeah.
will. I'll bring everybody around to the pay window. All right.
All right.
So, if this is your first time joining us, or if you just need a reminder, one of the things we do here is a giveaway to you in the live Zoom audience. One lucky person who answers our trivia question correctly will win an Oak D Lite. The way this works is you're going to answer in the chat window in Zoom. If you're not in Zoom, get into Zoom. It's opencv.live, but be quick. During the if you have won recently, please don't answer. If you won within the last 2 months, give other people a chance to win.
that's Phil's rule, by the way.
That's right.
Which is...
It's mean. I'm a mean old man. So during, get ready to answer. During the program here, we talked about a programming language called Logo. What year was Logo first released? Ha! Some of y'all were too early. Jesse, good guess, but you're too early. Jason, too early. Michael Weiss, it looks like 1967 was the correct answer. Congratulations, Michael. Please send one email to phil@opencv.org and we will make sure that you get your prize. Yeah, 1967, because that's pre-Pong. That's pre like almost all digital electronic amusements. Gosh.
It's 13 years before I was born.
Yeah, that's how long ago it was. Yeah, so we got time for a couple questions here.
Yeah, I'm looking at them. You want me to?
Yeah, I'll grab them out here so I can. John Morse would like to know, is the Oak D mounting bracket available individually? I was going to ask that myself because it looks really cool.
I don't think it is, but I can petition. Let me talk to Clearpath about that. Let me see.
Show them this video about how the people are clamoring for it.
Yeah, I will. I'll talk to him next week. I'll see what I can do. We'll see.
Excellent. Thanks. Another question here from John is, are there plans to create a version of this similar to the Husky that's made to work outside?
The TurtleBot? Not right now. I mean, I think that's a good idea. That's not in our roadmap. Let's put it that way. It might be in Clearpath's roadmap. Who knows?
Right on. Serge would like to know which. How do you decide to do this simulator stuff? What kind of choices do you have to make with, say, Gazebo to try to shorten that translation time from sim to reality? Can you talk a little bit more about that?
Well, I'm going to preface this by saying this is not a solved question. There's so many simulators out there, right? So there's like simulators that are particularly geared towards vehicles, right? Or there are other ones, that are more for, really good fidelity versus like, I want really good visual assets. There's no right one. It's sort of like a trade-off, it's an engineering trade-off analysis at the end of the day.
Mm-hmm.
Like which one is going to, I want to do this, which one is going to, work best for me? Which one has the features that it's going to get me there quickest?
Gotcha. Chris would like to know, if you write some software in Python with PyTorch, how is it possible to integrate that with a ROS system easily?
It shouldn't be bad. In the slides, I think I pointed to this new Foxy. I mean, it's a fairly new ROS package, but it's guy's got like Yellow X just running in a ROS node, and I think he did it all with PyTorch.
Yeah.
Cool.
You know, if you Google PyTorch ROS, you should be able to find something. It should probably just be as simple as like installing PyTorch and calling out from your node.
If you're, I mean, just to add to it, if you're actually developing or training a model using PyTorch, it doesn't matter because you can just train that model, export it to, OpenCV AI Kit format, which is the same as OpenVino format. And then that model will run no matter where you have trained it, right? On the OAK Lite. If it is a vision model, right, and you're using the OpenCV AI Kit for doing your inference, then that piece is already pretty simple.
Saying the tools you use to train it are sort of irrelevant because you're just going to be providing the trained model, not the whole method for training.
Yeah, most of the time PyTorch people use it for training the model, not really deploying
the model. Yeah.
Yeah, unless I'm wrong about people start using tools in different ways. So people can surprise you sometimes, but usually it is for training the model, and you can train the model separately and bring it to OpenCV AI Kit or ROS.
Right, definitely. John would also like to. John also noticed the Marshall amps in your background there. I don't think Kat plays. I don't think those are hers.
No, those are my partners, and we don't say the word because he'll slam in here. Oh, you want to talk about guitars?
I mean, again, that might have to be a separate show. We'll do OpenCV After Dark and talk about guitars and my collection of weird little synthesizers.
Oh, I have that one. It's over here actually.
That's probably my favorite pocket operator, the robot one. It's excellent. Pocket operator by Teenage Engineering, an incredible hardware manufacturer and designer. They're also behind the hardware for the Playdate, the new game console made by Panic, longtime Mac software developers, Panic. Really looking forward to that. Those just shipped, by the way, the first round apparently. Mine is going to come next month maybe, which I'm really excited about. It's a little tiny game platform that has a hand crank on it.
Super cool.
I'm trying my stuff.
Yeah, super cool. I kind of want one.
Yeah, I'm glad. I mean, because of the supply chain stuff, you had to order them super early. They went through stuff. But yeah, so to recap, if anybody wants OpenCV stickers and you're going to be at Embedded Vision Summit next week, hit me up. I will have some amount of them. I may make you answer a trivia question though. I can't promise that I won't. They may cost you either one beer or one. They might have to answer me these questions 3 like Tim from Monty Python. With that, Satya, you want to take us home?
Yeah, thank you so much, Kat. This was
no problem.
A great presentation. We learned a lot about TurtleBot, the history, as well as the new TurtleBot. And thanks, Phil, as always, for organizing this show. And thanks a lot to all our audience. We will continue doing this Thursday webinar, bring new people in. Thanks for your support.
Absolutely. And if you haven't got enough of me yet, you will be able to find me at Microsoft Build as well. So look for the OpenCV Spatial AI Contest breakout session. I'll see you there.
Yeah, and we will, Phil and I will also be at the Embedded Vision Summit next week. So please come and say hello if you're there.
I will be.
Come bug us. Buy me a drink.
I will be at ICRA in 2 weeks if anyone's going to ICRA, and Automate.
But will you have stickers is the important question.
Yes, I actually just ordered them.
Because you're a pro.
that is why.
All right. Sounds good. Thank you so much.
Yep. Thanks, y'all.
Bye. Thanks so much for watching this episode of the webinar. Please hit that like button, subscribe, and don't forget to tap the little bell icon to be notified when new episodes drop. This week's episode was brought to you by OpenCV Courses. Learn computer vision and AI from the best at opencv.org/courses. If you'd like to be in the audience next week, subscribe to the OpenCV newsletter.